What happens when the ultimate cutting tool meets an immovable object? We're pitting a lightsaber against a starship hull. But this isn't just about brute force. It's a battle of fundamental physics. What if that hull was designed to withstand weapons that could crack a planet? Could this elegant weapon from a more civilized age even leave a scratch? Let's run the numbers. First, what exactly is a lightsaber? It's not a laser. It's a blade of pure plasma, superheated gas with electrons stripped from their atoms, burning at millions of degrees. All that chaotic, intensely hot energy is contained by a powerful, precisely shaped magnetic field, a magnetic bottle. This focuses an incredible amount of thermal energy onto a razor-thin edge. When that blade touches something, it doesn't cut in the traditional sense. It transfers heat so violently and so quickly that it tries to melt or even vaporize the material on contact. But here's the key. It can only do that if the energy flows the target faster than the target can get rid of it. It's a race between energy transfer and heat dispersal. Now, let's look at the opponent. A capital-class starship hull isn't just a thick sheet of metal. It's a sophisticated, multi-layered composite system. The outermost layer is likely a ceramic or metallic alloy with an absurdly high melting point, designed to ablate or burn away to protect what's underneath. Beneath that, you have structural supports and further composite layers, each designed to stop different kinds of damage. But the real game changer is the active defense, a structural integrity field. Think of it as a force field woven directly into the ship's superstructure. Its job is to absorb kinetic shocks and, crucially for us, rapidly spread thermal energy away from any single point of impact. It acts like a super-efficient heat sink, diffusing a concentrated attack across a massive surface area. So the battle begins. The lightsaber makes contact. In our simplified simulation, the blade's immense heat immediately creates a superheated hotspot. But instantly, the hull's defenses kick in. The material's high thermal conductivity starts pulling heat away, and the structural integrity field goes into overdrive, shunting that thermal energy across the entire hull plate. The blade is pouring in millions of degrees of heat, but the hull is spreading it out so effectively that the peak temperature at the point of contact never gets high enough for a catastrophic melt-through. Now, could you get through eventually? Against a small, isolated, unpowered piece of hull plating? Yes, a localized breach is possible. You could poke a hole. But a full cut through a reinforced, actively fielded section of a capital ship? Extremely unlikely. The power required to overwhelm the heat dispersal of an entire starship's hull would be astronomical. You'd need to channel the output of a small power station through that hilt, and it simply isn't built for that. So, the verdict? You'd get dramatic sparks, some nasty surface damage, and a terrifying scorch mark for the repair crews to deal with. But a clean, movie-style slice through a fielded starship? The physics says no. The immovable object wins. If you enjoyed this deep dive, be sure to like and subscribe for the next episode where we ask, can a Star Destroyer's turbo laser melt a Borg cube? That one gets crazy.